Europe stands on the cusp of a major leap in space transportation. For decades, access to orbit in this region has relied on tried and tested vehicles built for reliability, autonomy and the institutional needs of governments and scientific organizations. But as global competition intensifies and the commercial space sector evolves at a breathtaking pace, Europe is shifting from maintaining mere access to space to enabling a far more capable, flexible and competitive launch ecosystem. At the heart of this transition lie three parallel ambitions. First, to build fully or partially reusable rockets that bring down costs and improve launch frequency. Second, to develop in-orbit logistics, tugs, depots and transfer vehicles that move payloads beyond simple drop-and-forget deliveries. And third, to integrate these advances into a sustainable, autonomous European space transportation service infrastructure. Together these efforts reflect not only technical ambition, but also strategic imperatives of cost competitiveness, independence and environmental sustainability. At present, Europe's standard-bearer launchers such as the Ariane 6 and Vega C offer solid institutional access to space, delivering satellites for Earth observation, telecommunications and scientific missions. But the global launch market is changing. Reusable first stages, propellant depots and responsive in-space transportation are becoming the norm rather than the exception. In recognition of this shift, the European Space Agency (ESA) has launched the Future Launchers Preparatory Program (FLPP), a vehicle for coordinating the technology development required for the next generation of space transportation. Through FLPP and associated initiatives, Europe is aiming to make reusable launch systems, in-space transfer vehicles and logistical hubs as commonplace as today's standard rockets. A key focus is reusable launch technology. Europe's engineers have recognized that simply maintaining the status quo in expendable launchers will leave the continent trailing in cost, flexibility and launch cadence. The Prometheus engine is one such cornerstone, a liquid oxygen, liquid methane design built for reusability, lower cost and versatility across both core and upper stages. Coupled with this is the development of the Themis program, a demonstrator focused on reusable first-stage recovery and reuse. As part of its long-term vision, ESA is exploring what is called a very heavy reusable launcher, capable of delivering up to 60 tons to low Earth orbit in a partially or fully reusable configuration. The ambition here is not just a technical demonstration but a credible business model. Europe must prove that large-scale reuse can make sense economically in its industrial context. In replicating the global move toward reusability, Europe is explicit about the motivations. Autonomy is one. Access to space must not be dependent on non-European providers. Competitiveness is another. Cheaper launches open the door to new markets, small satellites, constellations, commercial payloads, and reusability is central to that. Sustainability enters the equation as well. Fewer expendable stages means less debris, less waste and a more circular mindset toward space transportation. The drive toward reusable rockets isn't purely hardware-centric. The ecosystem that supports frequent launches and turnaround must also evolve. Beyond launch, Europe sees the next frontier of space transportation as the realm of in-orbit logistics. The FLPP describes a vision of reusable launchers carrying payloads to parking orbits, from where other vehicles, space tugs, move the payloads to their final destination, lunar orbit, Mars-bound trajectories, geostationary transfer orbits beyond Earth. The concept of a space tug or orbital transfer vehicle is no longer science fiction in the European framework, it is a concrete area of technology development tied into ESA's roadmap. To enable this, Europe is also looking at propellant depots, refueling in orbit and storage, transfer logistics, spacecraft arriving with fuel, transferring it to another vehicle, and enabling an extended mission lifetime or transfer further beyond. By doing so, Europe aims to move from isolated launches of standalone payloads to services that resemble transport logistics on Earth. You ride a launcher to a hub, switch vehicles, get fuel and go further. The transition to this integrated model involves several layers of technology and industrial transformation. For reusable rockets, Europe must master descent and landing systems, recovery of stages, refurbishment, rapid turnaround and cost-efficient manufacturing. ESA's first initiative seeks disruptive technologies in fields such as descent systems, landing and recovery, refurbishable interfaces and operations. For in-orbit logistics, Europe must develop rendezvous and capture mechanisms, propellant transfer systems, automated depots, and tugs that can perform reliably in orbit for extended periods. It is a systems engineering challenge as much as a hardware one. Equally, the business case must be credible. Frequency, cost reduction and standardization are enablers. Europe's approach emphasizes collaboration with industry, startups, service providers and the standardization of frameworks so that multiple companies can plug into a space transportation ecosystem. The vision is that launch, transfer, servicing, disposal and return become parts of one chain rather than discrete silos. Importantly, Europe's roadmap is paced and realistic. The Ariane 6 and Vega C systems will serve for the coming decade to maintain institutional access and provide security of supply. At the same time, preparatory studies and demonstrators are underway for the next generation reusable systems and in-orbit transport. For example, the Pathfinder activity is an ESA effort to map out the steps required for a future very heavy reusable launcher. The gradual nature of the transition reflects awareness that adoption of reuse is not just technical but economic and organizational. Stage recovery must make sense in terms of cost and industrial throughput, especially given Europe's smaller market compared to the US. Another major dimension in Europe's ambitions is environmental sustainability. The use of liquid methane for Prometheus reduces carbon footprint compared with some older kerosene-based systems, and Europe is explicitly designing rockets and upper stages with disposal or deorbit capability so as to reduce space debris. The aim is not only to launch more often and more cheaply, but to do so with less negative impact on the orbital environment and with a mindset of circular economy in orbit. This sustainability mindset aligns with broader European priorities in climate and industrial policy. In the competitive landscape, Europe is coming from behind in many respects on reusable launchers. Organizations such as SpaceX have already demonstrated frequent reuse and landed boosters multiple times. Europe's strategy is therefore partly catch-up and partly leapfrogging. Rather than copy exactly the US path, the hope is to build a system tailored to European industrial realities, with modular service providers, multiple companies contributing to an ecosystem and a long-term roadmap of in-space logistics. Europe's industrial model is more fragmented, smaller in scale and involves multiple nations, which presents both strength and complexity. Turning to the business perspective and commercial markets, the promise of lower-cost launches, reusable stages and in-orbit servicing opens new revenue streams. Small satellite operators, constellation providers, lunar logistics, servicing of geostationary satellites or space debris removal companies will all benefit from a robust European launch and in-orbit transportation ecosystem. Europe's vision is to build not just one new launcher but a transportation service network, launch vehicles, transfer tug vehicles, refueling hubs, servicing platforms and return-to-Earth capability. All of this dovetails with Europe's broader ambitions around sovereign access to space, strategic infrastructure, industrial jobs and technological leadership. From a strategic perspective, Europe's ambitions in space transportation reflect geopolitical and economic imperatives. Access to space is no longer a luxury but a necessity for communication, Earth observation, navigation, security and science. Dependence on non-European launch services introduces strategic vulnerability. By investing in domestic reusable launchers and in space logistics, Europe is asserting its autonomy and resilience. At the same time, global competition is intense, launch costs have fallen, new actors are emerging, and market share is shifting. For Europe to remain relevant and competitive, the shift to reusable, service-oriented space transportation is critical. But such transformation is not easy. Industrial restructuring, investment in new capabilities, alignment across nations and long-term financing all come into play. Looking ahead, one can anticipate key milestones for Europe's transformation in space transportation. In the near term, one expects the first demonstrations of reusable stages to occur. The Themis program is one such demonstrator. Mid-term, one expects partially reusable launchers to enter operational service perhaps by the late 2020s or early 2030s. Later, the goal would be fully reusable heavy-lift launchers, integrated in a space logistics network, possibly servicing not only low Earth orbit but lunar missions and beyond. In parallel, in-orbit transfer vehicles and propellant depots will become operational, enabling spacecraft to be refueled, repositioned and extended in lifetime. Europe's industrial base will shift from pure launcher manufacturing to full-chain space transportation services. Ultimately, the destination is not simply, go to space, but, move through space, with agility. In conclusion, Europe's space transportation goals are ambitious in scope but also pragmatic in execution. By focusing on reusable rockets, in-space logistics and a service-based transportation network, Europe is aiming for a future where access to space is frequent, flexible, affordable and autonomous. The transition won't happen overnight, it requires technology maturation, business case validation and ecosystem building, but the direction is clear. The continent is moving from static launch capability to dynamic, integrated space transportation, positioning itself not only to launch satellites but to build the infrastructure of space. For Europe to maintain industrial, scientific and strategic credibility in the decades ahead, these investments in launch and in-orbit transportation are among its most consequential.